Today we're going to be taking a look at the law of cosines. So law of cosines is used for triangles that are side, 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 or triangles that are side, angle, side. When you're given this information, you do not have enough information to use law of sines. So the next option would be to use law of cosines. So here are the formulas. These are different variations. If you are looking for side A, you would use this formula. For side B here, side C here. You can also reorganize the formula. You can isolate different variables to be able to also find angles. So to find angle A in a triangle, you would use this formula, and then of course you would have to do cosine inverse so that you could finally just solve for A. Same thing for angle B and angle C. All right, so what's important here to note is that you don't actually have to memorize these formulas because you can see they look a bit overwhelming. So let me just give you an example. If you were looking for side A, notice that the angle that you end up using is angle A. So you want to use the included angle. That means these two sides basically are adjacent to this angle, right? So you do the two adjacent sides, both of them squared. You subtract by 2 times those two sides again, but this time not squared, and you multiply by cosine of that included angle. So that pattern is going to be the same for all of the others. So let's go ahead and try an example. In this example, we have a figure given to us. We have a triangle drawn out. So we have all three sides. Side A is 8 feet, side B is 19 feet, and side C is 14 feet. And we need to figure out what all of those angles are. So because we have angles that are unknown, I'm going to use these formulas. All right. And again, these are just a rearranged version of this. Okay. So you don't have to, but I like to find the angle, the largest angle first. So if I look at the largest side, I'm going to go ahead and find angle B first and just get that obtuse angle out of the way. So we have the formula cosine of B is equal to, and then we have side A squared plus side C squared. So I have 8 squared, and then I have plus 14 squared minus, I'm going to subtract the corresponding side to the angle that I'm looking for. So that's 19 squared all over 2 times the adjacent. So 8 times 14. All right, so I'm going to go ahead and plug that into my calculator. So let me bring up the calculator. All right, so we have 8 squared plus 14 squared minus 19 squared. I'm going to go ahead and evaluate that numerator. All right, and then I'm going to divide that. And I'm going to divide that by an entire denominator, so I'm just going to group all of those. 2 times 8 times 14. All right, and they end up getting negative 0.4508, and so on. All right, so now what I need to do is, I know that cosine of B is equal to that. So let me show you what I have here, just simplified. Right? So I evaluated all of this in the calculator, and I ended up getting this decimal. So what I need to do now, because I'm trying to find angle B, is I need to do cosine inverse of both sides. That's how I'm going to get rid of that cosine. Okay, we know by now that we're just going to copy this entire value in the calculator. So these will go away, and we are left with B, and I'm pretty positive we're going to have to round. So let's go back to the calculator, and let's see what cosine inverse of that is. I'm going to do second cosine inverse. I'm going to copy that value, and we get, oh, you know what? Sorry. I am in radians, so I need to change my degree, my mode to degrees. So let's try that again. That looked a little bit off. So I'm going to copy this entire line again, but now I'm in radians. I'm sorry, I'm in degrees. There we go. So approximately 116.8 degrees. All right, so if I go back to my drawing, I have 116.8. All right, now I can go ahead and find either of the two other angles. And at this point, I do have an option. I can use either one of these formulas to find the angles, just like I did for angle B. But now I actually have a complete set. Notice that I have side B and angle B. So I could use law of sines if I wanted to. So I'm going to go ahead and try that. All right, so in the next step, all right, let's go ahead and find side C. I'm sorry, angle C using side C. So I'm going to do sine of C, I'm using law of sines now, over its side. So that's 14. And then I'm going to do the same thing, but with that complete set. So I'm going to use the B's. So sine of angle B, which is approximately 116.8, all over 19. And to isolate C, I'm going to multiply by 14 on both sides. So I have sine of C is equal to sine of 116.8 degrees all over 19, and all of that times 14. So let's go to the calculator and see what that gives us. Alright, so we have sine 116.8. I could have actually just copied that exact value, but I just deleted it. Will be close enough though. So I'm going to divide that by 19. Then I'm going to multiply that by 14. Right, and I get sine of C is equal to 0.6576 and so on. So I need to know angle C, so I'm going to do sine inverse of this entire value. So for angle C, we get approximately 41.1 degrees. Alright, so now I have found this angle right here, which is 41.1 degrees. So now the next step is pretty simple. We know that in a triangle there are 180 degrees. So all I'm going to do now is 180 degrees minus 116.8 degrees minus 41.1 degrees. And let's see what we get. So I have 180 okay, it's not typing. Let's see why. Okay, 180 minus 116.8 minus 41.1, and we get 22.1 degrees. Alright, so now we have solved for that last angle, 22.1 degrees, and we have completely solved that triangle.